Hey everybody, welcome. It's a presentation on how climate change is worsening California's wildfires and how to solve it. We'll be getting started in a moment or two. Thank you for joining.
Thanks, Stuart. Hi, everyone. Thank you for taking some time out of your Thursday evening to join us on this incredibly important topic. We'll be discussing the link between climate change and wildfire risk, what we know about what has occurred, what we can expect going forward, and what, most important maybe, what we can do about it. My name's Jerry Hinkle. I'm an economist and I work for Citizens Climate Lobby, and much of this will surround our work and our solution, but we'll broaden it beyond that because we want you very much to leave here taking strong climate action regardless of who you do it with. So here are the points of the presentation tonight. This is completely nonpartisan, as CCL is. You're not going to get my opinion or Dana's opinion. I mean, that will sneak in on occasion, but really we are presenting the peer-reviewed science and the peer-reviewed economics on this issue. You get enough opinions on this. We're trying to cut through that and give you what's so about this. Here's what we know from the peer-reviewed science. Climate change is the primary component of increased wildfire risk. There are other components, but it's the primary for the increase in wildfire risk. Unfortunately, we also know future wildfire risk, it's going to get worse before it gets better, but we can stabilize the risk. And you have a huge difference to make on this issue because what happens going forward, the degree to which this risk expands depends on our action now. So we have much say in the matter for our lives and for what we leave our children with. And I want to assert we generally know what to do. There's enough information out there. We know how to solve this. We have a fair, effective, bipartisan solution. It stabilizes climate risk, greatly improves health in the country, grows jobs in the economy, and there are actually, it's a political issue. There are several bills before the House and Senate now that would absolutely get the job done of stabilizing climate risk, including one we'll talk a little bit more about tonight, HR 763. And then we'll end the evening with very specific action steps you can take to make a difference on this, because what we've got, it's a political issue. We know what to do. We know the risk is enormous. And what we need right now, it's money against people to a good degree, and we just need you to have your voice heard. We need you to reach out to your congressman and impact that political process. I'm now going to turn it over to Dana Nuccitelli, who's going to go for the science.
All right, thanks, Jerry. And at the end, we're also going to do a Q&A session, and we'll, when we get there, we'll explain to people how to enter your questions for us. So I'm going to really quickly just hit my background. My degrees are in physics and astrophysics from Berkeley and Davis, and then I became an environmental scientist in 2006, which is also when I got interested in climate change, started learning about climate science. And in 2010, I started writing about it for skepticalscience.com, and then for The Guardian in the UK, and from 2013 and 2018, about 5.5 years there. In 2016, I got the Friend of the Planet Award from the National Center for Science Education, which means I get to say that I'm an award-winning climate journalist, which I just think sounds cool to say, so I like to say it. And then about 2 years ago, I started writing for a group called Yale Climate Connections. I've published some peer-reviewed climate science papers. I've published a book, Climatology versus Pseudoscience, which, we're getting close to the holidays, and it makes an excellent gift for all your friends and family. Just go to Amazon and plug in my name and it pops up. And then I'm a member of the Sacramento chapter of Citizens Climate Lobby, and also I'm the lead on the science team for a Citizens Climate Lobby National. So yeah, I started writing for Yale Climate Connections in November 2018. At the time, it was the worst wildfire season in California's history, or since we've been keeping records, was ongoing. And so the first piece I wrote for Yale Climate Connections was on the ways that climate change worsens California's wildfires. And so then the next year in California, we got lucky with some nice, relatively cool and wet weather. So we had a mild wildfire season, but in the Southern Hemisphere, Australia got their worst bushfire season on record. So I got to write about that in late 2019, early 2020. And I think this is an important point because a lot of people like to try to blame California for our wildfires, but it's important to realize that it's not just California that's seeing these record wildfires. It's also Australia. There's some happening in Brazil, other states, Washington, Oregon, Idaho, Montana. Like there's wildfire problems all over the place. So it's not like it's just a California problem. And then, of course, we had this year another record-shattering wildfire season. So a couple weeks ago, I wrote another piece on that for Yale Climate Connections. And then my colleague, Daisy Simmons, she lives in Nevada City, and she actually was evacuated from her home because of encroaching wildfires. And so she wrote about what that was like, kind of steps that are smart to take if you're in danger of being evacuated due to wildfires. And so that's really worth reading too, just yaleclimateconnections.org. We got a lot of good stuff there. All right, so let's get into the statistics. This is a list of the 20 largest wildfires on record in California from CAL FIRE. So you can see the #1 largest fire, the August complex, numbers 3 and 4, the SCU and LNU lightning complex, the #5 North complex fires were all ignited in August of 2020. So we're going to look at what the heck happened in August 2020 to ignite all these huge wildfires. And then September, we had the Creek Fire, which is a little further south. We're going to look at some satellite images of where these all are. So 5 of the top 6 biggest wildfires on record in California have happened in the past 2 months. So it's been pretty insane. And then the August complex is up to about 860,000 acres now. The previous record was about 460,000 acres. So it almost doubled the previous record largest wildfire in California. So there's just like insane things happening this wildfire season in California. So this is a satellite photo. The orange is artificially added to show where wildfires were burning. This is on August 20th, but all the smoke and everything is just from the satellite image. It's just the orange that's added. So you can see right there, that's where the August complex fire began. And just north of it was called the Elkhorn fire, but they kind of merged into one super fire. So that's why the August complex became by far the largest wildfire on record in California. Down here, you can see the SCU and LNU, the 3rd and 4th largest surrounding the Bay Area there. And that's the North Fire, kind of just at its beginnings over by Chico. That was the 5th largest wildfire on record. So that's the 4 of the top 5 biggest wildfires on record in California, all happening on August 20th. And we're going to talk about what happened there. And then another kind of mind-blowing statistic was this is what the August complex wildfire looked like a couple weeks ago, and it actually has grown to be larger than the state of Rhode Island. So we have one wildfire that's already bigger than a state, and then if you combine the area burned by all the wildfires in California this year, it's bigger than the state of Connecticut, I believe. So just a huge area that's been burned this year by all these wildfires. So after mid-August, that's kind of when the first set of wildfires were ignited and started growing. And then there was kind of a second period in September 6th through 10th when wildfires kind of got out of control again. So I'm going to show a little video here. It's going to start on September 4th here, and it's going to progress through September 10th. So you can see how these wildfires have grown. So there's the 4th, and then it's going to progress to the 5th here. And so you can see a lot of smoke coming from here. That's the Creek Fire down near Fresno. Here's the 6th. This is when the fires really started to grow. This is the August complex up here. And you can see up here on the 7th, the North Fire is going to start growing. You can see all the smoke covering the entire state. So there's the North Fire on the 8th, really billowing a lot of smoke towards us here in Sacramento where I am. And then here's the 9th. You can see the big August complex fire here, pretty much the whole state covered by smoke. And here's the 10th, the entire state covered by smoke, smoke going way into the Pacific Ocean, into Arizona. You can see all these big wildfires kind of artificially added beneath the smoke. And then the smoke has, reached not only the East Coast of the United States, but it's actually reached parts of Europe as well. So major fire growth during that period. So I'm going to look at a chart showing that. So this is the annual acreage burned, again, from CAL FIRE since 1987. That's kind of when we had good records beginning due to satellites having cameras. So before the 80s, the records for wildfire area aren't so reliable. So you can see each of these years represents, or each of these bars represent 1 year, except for the very last one here. That just represents those 5 days we just saw between September 6th and September 10th. So you can see during that time, we had 1 million acres of area burned by wildfires, and that's more acreage than most entire years prior to that, more than 28 of the previous 33 entire years. So, each of these bars represents 365 days, and this bar represents 5 days. So that's when the wildfires really just blew my mind that, on average, an average year between 1987 and 2011, about 500,000 acres burned in California. And on September 6th through 10th, 2020, 1 million acres burned. So twice what an average year used to burn. And then it just so happens on September 5th, we had already broken the record for the largest wildfire season, which was in 2018, which was just below 2 million acres. So we reached 2 million acres on September 5th, and then we burned another 1 million acres on September 6th through 10th. So at this point, we're way up above 3.6 million acres burned. So, and there's still quite a bit left of the wildfire season to come. We've got another heat wave coming this weekend, and then the windy season's coming. So in all likelihood, we'll more than double the previous record set just 2 years ago in terms of acreage burned by wildfires in California in 1 year. And then you can see this long-term trend going upwards with the wildfires getting larger and larger over time. So that's all kind of discouraging stuff, especially for those of us who have been living through these fires and smoke and unhealthy air quality. So that's the bad news. The good news is that you can see from this chart, 2018 or 2020 is still an outlier. This is not yet a normal year. This is still a crazy year in terms of kind of recent history of wildfires. So in my Yale piece that I wrote a couple weeks ago, I made the comparison to Ebenezer Scrooge in A Christmas Carol by Charles Dickens. Mostly because I thought that by referencing Charles Dickens, I would sound smart and sophisticated, and that's always a good thing when you're writing for Yale. But I'm sure we probably all agree that the best version of the story is The Muppet Christmas Carol, so I'm going to kind of let them set the scene to show what I'm talking about.
Am I in the presence of the ghost of Christmas yet to come? Spirit, I fear you more than any spectre I have yet met.
This is too scary. I don't think I want to see any more.
No, when you're right, you're right. You're on your own, folks. We'll meet you at the finale.
Yeah. Oh.
All right, so as the story goes, the ghost of Christmas yet to come takes Scrooge to look at his future if he continues on his kind of business as usual behavior path. And it's really bleak, of course, he's dead and everybody's happy about it, and they're celebrating and basically dancing on his grave, and Tiny Tim even dies, and it's just miserable and bleak. But then he goes back to the present, and he realizes he can change his behavior and thereby change the path that he's on and change his future outcome. So that's basically exactly what's happening with us now with the wildfires. We're seeing if we continue on business as usual, burning lots of fossil fuels, pumping tons of carbon into the atmosphere, increasing global warming, we're going to see more and more wildfire seasons like this one. But if we change our path, reduce our fossil fuel consumption, reduce our greenhouse gas emissions, get emissions down to zero, then we can make years like this still become relatively infrequent. And so we can still, improve our future so that it doesn't look as bleak as it's starting to look right now. So let's hop back to this year and look at specifically what happened in August to ignite all those crazy, huge wildfires that we've been seeing. So this is kind of an image from August of 2020. You can see this thing they call a heat dome sitting over the southwestern United States, including California. So that's basically like a high pressure ridge that traps heat, hot air in one spot. So this hot air was just sitting over the southwestern United States for basically the entire month of August. You can see this pattern in the atmosphere, this wavy pattern in the jet stream. We're going to come back to that and talk about that in a little bit. So kind of keep that in mind. So because of that heat dome, it was really hot month. This is the average temperature in California for the month of August every year since 1895 from NOAA. You can see over here, that's 2020. The average was 79 degrees Fahrenheit across the states for the entire month, all times of day. And so for comparison, the previous record was a couple years ago. It was a little under 78 degrees Fahrenheit. So it was more than 1 degree Fahrenheit hotter than the previous record. So record-breaking hot month. And if the average is 79 degrees Fahrenheit, of course, we're going to have a lot of extremes much hotter than that. And so, those of us living in California, of course, remember that we were having like weeks on end of 100-degree days every single day. Death Valley had the most reliable, or the hottest temperature ever reliably recorded at 130 degrees Fahrenheit. So it was just an incredibly hot month, thanks in large part to that heat dome sitting over the whole Southwest. At the same time, there was this tropical storm Fausto. This is an image from August 16th. It was off the coast of Baja California. You can see like this is southwestern United States where that heat dome was. And so this tropical storm came along and the heat dome kind of sucked in moisture from the tropical storm. And what resulted was a whole ton of lightning storms. So this is an image, it's a photograph of the Bay Area on August 16th. There's a whole bunch of these. If you like Google lightning strikes in August in California, you can see all kinds of lovely photos of lightning strikes. So there was over a 3-day period in the middle of August, there was something like 11,000 lightning strikes across the state over 3 days. And this was in the middle of a record-breaking heat wave. So any precipitation that fell from these storms that evaporated before it reached the ground. And we're already in the middle of summer. And so basically this is your perfect storm where you get really hot conditions. It was actually already a dry year because it just happened to be this year. California didn't get a lot of rain. It was 60% of average. It's in the middle of summer, so we don't get rain in the summer anyway. So it's super dry. You get these freak lightning storms. None of the precipitation is reaching the ground. And so these conditions are just perfect for these so we had hundreds of wildfires get ignited, and because it was so hot and dry, they spread really fast. And that's why we had these 4 of the top 5 largest wildfires on record in California ignited basically at the same time because of these lightning strikes in the middle of August 2020. So yeah, it was pretty crazy. As a result, we were having for quite a lot of August and September the worst air quality in the world. This is an image of air quality data around the world on September 12th. I just picked that date because there was the entire West Coast was having problems actually. You can see there were wildfires in Oregon and Washington and Idaho and all of these different places, and it was creating air quality that was somewhere between unhealthy and hazardous, basically on the entire West Coast and even a little bit inland. Worst in the world. I say again on this slide because back in 2018, when I was writing about the then record wildfires, I was saying the exact same thing. California, we have these record wildfires, and we have the worst air quality in the world. So it's kind of deja vu. It's happening again. And it's a real big health threat when we keep having these huge wildfires. We get all the smoke in the air and we get really unhealthy air to breathe. And it's a bad thing. So unfortunately, there's been some voices that have tried to politicize the wildfires, and it's something that really aggravates us scientists because there's like an objective reality what is causing these wildfires to get really big over time. And unfortunately, some voices are just trying to make it a partisan issue. So you can see on this particular show, you got this Chiron Democrats blame the wildfires on climate change. And then later in the segment, they say the fires, we believe, are actually the result of forest mismanagement and the buildup of wood fuel. So it's like the left believes this, it's climate change, and the right believes that it's forest management. And the reality is that it's both things. And like when people try to politicize that and say the right believes one thing and the left believes another thing, it just drives scientists crazy, because like we want people to like look at the scientific evidence and accept what the evidence says and what the objective reality is. So we're going to look at both of those different factors. So this is a chart from a paper published a few years ago. You can see it's talking about biomass burning in California, which is basically the amount of trees and other vegetation that have been burning every year. So we are right around here in the current era. You can see that the biomass burning is actually relatively much lower than it was hundreds of years ago. And in this chart, in this paper, they call it the late 20th century fire deficit. So that's because especially over the past 100 years in California, we have been very aggressive in doing fire suppression. We haven't allowed kind of good fires to burn and basically remove a lot of vegetation. So, hundreds of years ago, Native Americans did this kind of thing where they lit fires on purpose and let them burn in a controlled fashion to do forest management. And then they got displaced by European settlers, and that practice kind of started to fade away. And then 100 years ago, we became really aggressive in putting out every fire that we could. And so that certainly is one contributing factor, that there's been a lot of buildup of vegetation that is acting as wildfire fuel. And so over excessive fire suppression, which is a form of forest management, is definitely one contributing factor, but it is not the only contributing factor. So there's a lot of research into this. And so there's a report that's done regularly called the National Climate Assessment Report. It's basically the US version of the IPCC report, where it's like our best scientists kind of look at the latest and greatest climate science and summarize it into one big report. And one of the things that they looked at was what's causing wildfires to get worse in the Western United States. And so their conclusion, this was mostly based on a report, a study in 2016 by these guys, John Abatsoglu and Park Williams, who we're going to hear more from here in a little bit. Their conclusion was the area burned by wildfire from 1984 to 2015 was twice what would have burned had climate change not occurred. The area burned from 1916 to 2003 was more closely related to climate factors than to fire suppression, local fire management, or other non-climate factors. So yes, fire suppression, forest management, other factors like that are playing a role, but climate change is playing a very, very big role. It is the biggest single contributor to why wildfires in the West are getting worse, because it dries forests and makes them more susceptible to burning. And they had this very nice chart to go along with that part of the reports. So this is the cumulative area burned. So you're adding the area burned in a given year to all the area burned from the previous year since the 80s. And you can see the yellow is the area that would have burned without climate change. And the orange is the additional area that burned because of climate change. So as you can see, as that quote said, that's a doubling of the area burned if climate change had not occurred. So twice as much area burned as would have otherwise because of global warming. Just recently, coincidentally on August 20th, which is that middle of August that we've been talking about, there was a very relevant paper published by a whole bunch of like the foremost experts on California wildfires and climate science. So there's John Abatsoglu and Park Williams, who I mentioned. There's Daniel Swain, who's a climate scientist at UCLA, who we're going to hear more from him in a little bit. Michael Goss and Noah Diffenbaugh out of Stanford are really good climate science experts too. And I mean, the title of the paper kind of gives away the point, but they say climate change is increasing the likelihood of extreme autumn wildfire conditions across California. And so this is kind of the money chart from that report. So it's looking at the fire weather index, which is basically a combination of how hot and dry and maybe windy, basically the factors that make the conditions bad for wildfires. So it's putting those all together into one measurement. And these are days that are above the 95th percentile, which means it's the 5% worst conditions for wildfires. And then we're looking at September, October, November, so the autumn months only. And then they look to see how the number of days with these extreme wildfire conditions in the autumn has changed since the 80s. So you can see in the 80s, they were very rare. There's only a few days per year where there are these extreme wildfire conditions in the autumn because it was relatively cool and wet in these fall months. But then over time, we've gotten more and more and more and more of these extreme wildfire condition days in the fall months. And we've more than doubled the number of days that we're seeing these extreme wildfire weather conditions in September, October, November since the 1980s. So very consistent with that previous finding of a doubling of the area burned by wildfires. This is saying we have a doubling of the most risky wildfire days in the autumn months. So why is that happening? Two factors that they identified. One is pretty simple. Global warming is making temperatures go up, which is increasing the heat. So this is again NOAA looking at California's temperatures, but this time it's from September through November, so those autumn months. So around 1900, the average temperature in California in the autumn was about 58 degrees Fahrenheit. Now it's up to about 61 degrees Fahrenheit, so several degrees hotter. And of course, when the average is hotter, then again, you have more and more of these days that have extremely relatively hot temperatures. And so when you have those relatively hot temperature days, that's when you have the conditions that are really bad for wildfires. So that's the first factor, is that it's just hotter, which means it's worse conditions for wildfires, more of those really extreme days. The second factor is that in California, we're seeing a shift in our rainy season. So this chart is from a 2018 paper by Daniel Swain, who I mentioned from UCLA. So it's looking at this black line across the middle is the average amount of precipitation in each month in California before the Industrial Revolution, so before humans started to impact the climate. And then these lines, the kind of brownish, yellowish ones are Southern California. The greenish ones are Northern California. In California, or in Sacramento, Bay Area, Lake Tahoe, we're kind of in the white to green latitude range. And so you can see in the winter months, December, January, February, the colored lines are above the black line, which means in those months we're seeing more rain than we used to. Whereas in the fall months, September, October, November, all the lines are below the black line, meaning we're seeing less precipitation in the fall months, especially September, October, but also into November. And then the same thing's happening in the spring, especially April and May. All the lines are below the black line, meaning we're seeing less precipitation in the spring as well, which basically means, because in California we have this Mediterranean climate, we basically don't get any rain in the summer months already. And so the dry season's starting earlier. It's starting in April or May instead of starting in June. And then it's ending later in like October, November, December, instead of ending in like September, October. So this decrease in autumn fall rainfall that they mentioned, or that they found, is the second contributing factor to why those extreme wildfire conditions, the fire weather index, is getting worse in the fall months. So higher temperatures and less rainfall in those months. So in that paper that was just published a month or so ago, they used some language that's familiar to a lot of us who are in the climate space. We all know that the Department of Defense, the military, likes to talk about climate change as a threat multiplier, has called climate change a threat multiplier for a long time now. And in this paper, they say climate change can be viewed as a wildfire threat multiplier because it amplifies the natural and human risk factors that are already prevalent throughout California. So we already have our dry season in the summer. We already have these forest management issues. We already have power lines that go down and spark fires. So we have these natural and human risk factors, and then you add climate change that makes it hotter and drier and multiplies those existing risks for wildfires, and that's why it's a threat multiplier. They also tried to look at what these extreme wildfire condition days in the autumn are going to look like in the future. So they got a couple of charts. The one on the left is Northern California. The one on the right is Southern California. The red line is kind of worst case, burn lots of fossil fuels, lots of global warming. The blue line is sort of, we take some action to reduce global warming. We don't hit the Paris climate target. We go a bit beyond that. So it's kind of a middle moderate scenario. And again, we're looking at the fall days with the extreme fire weather index, the number of days in the autumn where you have really bad wildfire conditions. So you can see in that worst case scenario, it just keeps going up and up and up and up. We get more and more of these extreme days if we don't do anything to get global warming under control. If we take the other path and get global warming under control, you start to see that level off. And we still see more days where there's these extreme wildfire conditions in the autumn, but the increase is not nearly as bad as if we don't take action and we keep burning fossil fuels. So this is kind of our two paths. This is your, Ebenezer Scrooge continues on his business as usual versus Ebenezer Scrooge changes his behavior and starts being a nicer person. They also put it in kind of map form. So that's one on the left, that's equivalent of the blue line. That's when we hit 2.5 degrees Celsius. Again, the Paris target is 2 degrees Celsius above pre-industrial temperatures. So we missed that by a little bit. The right one is if we hit 4 degrees Celsius, which is basically like a catastrophic global warming scenario. For perspective, the last ice age was about 4 to 5 degrees Celsius colder than it is right now. So 4 degrees Celsius is like a huge, huge difference on a global scale. And so you can see the red is like 12 to 20 days of these extreme wildfire conditions in September, October, November. And so you can see, you know, in the left side, there's a fair amount of red. You know, we're still seeing an increase in these extreme wildfire condition days. Although again, we can do better than this if we hit the Paris climate target. But on the right side, I mean, it's substantially worse. The entire Sierra Nevadas, like they have a lot of these extreme wildfire days, Northern California too, and down on the south coast. So it's a pretty stark difference between the scenarios where we continue with burning lots of fossil fuels versus getting our global warming under control. So a related event in California was this drought that we had from 2012 to 2016 that actually is related to the wildfires as well. So there was a really good study where these scientists went around California and they found trees and they drilled these cores into the trees and they looked at the width of the tree rings going back in time. So they were able to reconstruct the intensity of California's droughts over 1,200 years. And they found that the drought from 2012 to 2016 was the worst in California during that entire 1,200-year record. So it was a really, really bad drought. And that kind of wreaked havoc on California's forests. So this is a chart of the number of trees dying each year in the Sierra Nevadas. So you can see 2010 through 2013, not a whole lot of trees died each year. It's less than 1 million each year. And then 2014, as that drought kind of started to hit its stride, we had a little bit of a jump in the number of trees dying. And then 2015, there were like 18 million trees that died. 2016 was kind of the peak of the drought. There were like 55 million trees that died that year. And then the drought started to wane in 2017, 2018, but there were still like 20 million dead trees in 2017. And I think it was about 15 million dead trees in 2018. So this happened due to a combination of factors. So one thing that happened was the drought was because we had this intense drought, it put a lot of water stress on the trees. And then 2014 through 2018 were also the 5 hottest years on record, both globally and specifically in California. So the trees had a lot of heat stress. And then a third thing that happened is that bark beetles are normally, when there's a cold winter snap, it will kill bark beetles and reduce their population. But because these were the 5 hottest years on record, the winters were also relatively warm. And so more bark beetles survived into the spring and summer months and kind of spread out and decimated a whole bunch of trees. So we had this combination of water stress, heat stress, and then bark beetle stress that just kind of all combined to kill a whole bunch of trees. It turned out to be somewhere in the ballpark of 150 million dead trees in the Sierra Nevadas because of these combining events that were all linked to global warming. So then we get a lot of people saying that California has a forest management problem. And I mean, the problem is, that is true, but forest management is a difficult issue when you have 150 million dead trees in the forest. How do you even go about removing 150 million dead trees? They don't have any commercial value because you can't use them for lumber because they're dead trees. And so you can't get any companies to help you pull them out. No industries will pull those out for you. And so basically, and then another issue is that 57% of the forest land in California is owned by the federal government, and it's kind of the oversight is from the United States Forest Service. And so, sure, the Forest Service can hypothetically try to remove these trees, but it doesn't have the budget or resources to do that. So we need a vastly increased budget for them to do that. Or another thing we can do is a lot more controlled burns, but that's also a challenge because California has really bad housing policy. And so it's really hard for people to afford living in like the Bay Area or cities. And so more people are moving out toward the wildland urban interface and living kind of on the edges of these forests. And so you can't really do a controlled burn when there's a house there. And so there's all these complicated factors that make forest management really difficult. So it's easy to say California needs to manage its forests better. But, for one thing, climate change is making that harder by killing these trees. There are other, housing policies making it more difficult. The U.S. Forest Service needs a much bigger budget to help with that. And then there needs to be collaboration between the state and federal government. So it's just a really complicated thing to do. But it is true, forest management is a problem. And we do need to do more controlled burns and allowing good fires to burn. So let's go back to look at that drought a little bit. So this is an image from around 2016 when the drought was happening. You can see this high pressure ridge kind of looks a lot like what we were seeing with the heat dome earlier. So this is a high pressure ridge sitting off the coast of California, and it was just kind of sitting there, kept coming back and back and back, 2012, 2013, 2014, just would not go away. And so Daniel Swain, who we've been talking about, came up with the name, the ridiculously resilient ridge, just because it kept on coming back, it would not go away. And so what would happen is you'd have a storm coming across the Pacific Ocean toward California, and it would hit this high pressure region, it would just get diverted up to the north. And so the precipitation, instead of falling on California, was falling mostly like to the north of us in Canada and Pacific Northwest and Alaska. And we weren't getting very much rain. And that was one of the big contributing factors to this drought. And so again, you can see this wavy pattern in the jet stream. So it looks a lot like that high pressure, or for that heat dome did just last month. And so there is a new theory in climate science where they believe that changes in the Arctic are changing the jet stream and creating more of these wavy patterns. And so Jennifer Francis is a climate scientist from Rutgers who is kind of the pioneer of this theory. And so I'm going to have a little video of her explaining the concept.
The reason there are jet streams is because of the differences in temperature between different sections of the world. And that difference in temperature is what creates the force that drives these winds. As global warming is occurring, the Arctic is warming much faster than areas farther south. That means that this difference in temperature is not as large as it used to be. And so there's less force driving the winds of the jet stream. When the jet stream gets weaker, when those west to east winds slow down, the jet stream tends to travel in a wavier path. They're actually what create the dynamics in the atmosphere that creates weather patterns. Once those waves get quite large, then the weather patterns can become so slow that in effect they get stuck.
Yes, I mean, we can think of the jet stream and these atmospheric air currents. They act very similarly to the current in like a river. So you can think when a river is, the current is moving really fast, it tends to go in a straight line. And when a current slows down, then it can tend to meander. And so the same thing happens with these atmospheric air circulations. So as Jennifer Francis said, the temperature difference between the Arctic, which is obviously really cold, and lower latitudes like here in North America, that difference in that temperature creates a force that basically makes that current move faster and it stays more in a straight line. So the Arctic, however, it's actually the fastest warming region on the planet. It's warming about 3 times faster than the rest of the planet as on average. And so because it's cold, but it's warming really fast, the temperature difference between the Arctic and the lower latitudes is decreasing. And so there's less of a force pushing on the jet stream. And so we get more of these wavy patterns in the jet stream. And so that's creating more of these situations where you got a wave in the jet stream. Instead of moving the weather systems along, the weather systems just get stuck in one place. So we saw that with the heat dome. We saw that with the ridiculously resilient ridge. We also see that more with hurricanes these days, because hurricanes they're called steering winds that move the hurricanes along. But when the steering winds are weak, then the hurricanes can start to move really slowly. So for example, just last week, there was Hurricane Sally that was moving at like 3 miles an hour. And it just kind of sat over the Florida Panhandle in Alabama and dumped like feet of rain into like one spot. Another example was Hurricane Harvey. Did the same thing to Houston a few years ago. It just kind of sat over Houston in that part of Texas and dumped feet of rain into one spot because the winds were not moving it along. And so we're just seeing more and more of these situations where, because these atmospheric air circulations are not moving as fast as they used to, weather systems are getting stuck in one spot. And you can, as a result, you get more of these extreme weather conditions. So the main reason the Arctic is warming so fast is because of disappearing Arctic sea ice. So this is going to be a video my colleague Andy Lee Robinson made. So this ice cube on the left is the volume of ice in the Arctic Ocean in 1979. And then the ice cube on the right is going to change to show the volume each subsequent year. And then the 2020 melt season just ended, and it looks like it's going to be about the same as 2019. So you can see it basically lost about 3/4 of the volume of ice in the Arctic Ocean over the past 40 years. So the result of that is that when there is a layer of ice on top of the Arctic Ocean, then when sunlight comes down, it hits this reflective ice and it bounces back up to space and it keeps the Arctic cold. But when the ice melts and is no longer on the surface, then the sunlight comes down and it hits dark ocean. The dark ocean absorbs the sunlight and makes it warm, which then melts more ice, which then causes it to absorb more sunlight, which that then warms it more and melts more ice. And you get this feedback effect where the Arctic is warming really fast. And so I'm going to abuse the cliche and say, what happens in the Arctic doesn't stay in the Arctic, because you would think, when the Arctic sea ice is disappearing, that's just going to affect polar bears. It's not going to affect me. And like it's true, it's really bad for polar bears, but then it seems to be affecting these atmospheric air circulations that then affects weather patterns all over the world, and it affects all of us, even though it's way up in the Arctic. So I'm just going to now summarize kind of what we've just talked about. So the most direct way that we know climate change is making wildfire worse is that it's increasing temperatures, which means more heat, which means more evaporation from soil, more transpiration from plants, which basically means everything gets drier. And so then when a wildfire gets sparked, it spreads further and faster than it would otherwise have spread because of these really dry conditions caused by higher temperatures. And then we also know in California specifically, we're seeing these shifting rain patterns where we're getting less rain in the fall months and also in the spring months, which basically means the wildfire season is getting longer. Again, things are getting drier and they're staying drier further into the year. And so that's why we're getting more acreage burned, more area burned, more and more over time, because the wildfire season is getting longer and longer. And then we have this kind of more tenuous, still a subject of more climate science research, but we are seeing that the wavy jet stream caused by changing the Arctic appears to be causing more of those wavy patterns, which is then causing weather patterns to get stuck in one spot for a longer periods of time. So that may contribute to these kinds of things like heat domes and droughts that cause even worse wildfire conditions. So again, that's still kind of bleeding edge climate science. It's less, we're less confident in that than we are in those first 2 points. And then we know climate change is a threat multiplier. So my kind of crass way to boil that down is to say that shit happens. You have already conditions for wildfires in California. Maybe you have an ongoing viral pandemic that affects people's lungs and other organs. And then you get climate change making it hotter and drier and putting more smoke in the air that people are breathing that then affects their lungs and other organs in the same way. And so basically climate change takes shit and then it turns it into a shitstorm. And so I think we can all agree that 2020 has been one big shitstorm, especially in terms of this insane wildfire season we're seeing in California. And that's all very discouraging. But again, I want to come back to the kind of hopeful point that we still have control over how bad these wildfire seasons are going to become in the future. And so I'm going to turn it over to the Muppets again really quickly.
Oh, Bridget, would you and your family care to join us for a little turkey dinner on this fine Christmas day? Merry Christmas. Merry Christmas!
So yeah, solar panels and wind turbines for everybody. Yay, let's solve the problem. So be like Scrooge, try to change we need to change our behavior, get off of our business as usual path of burning lots of fossil fuels, get towards these clean energy solutions, and then we will see a future that has years like this that are relatively infrequent as opposed to years like this that are more commonplace. So I'm going to turn it over to Jerry, and he's going to tell us how we're going to make that happen. So Jerry.
Wow, Dana, thank you. Just a fabulous presentation. Yeah, and I'll go ahead and start. Oh, where is
And
that?
while you're getting that up, I'm going to say one thing about
Please.
questions. So everybody, if you have questions or clarification, anything you want to ask about anything Dana went through or what Jerry's about to go through, you can go to the Poll EV link that I've posted in the chat, and you can post a question there. Now, maybe you're not the question typing type, but we'd like to hear it. You can go there and you can upvote and downvote the questions that have been posted, and that will give us information on what's most popular with the group. So even if you don't have a question in mind, go there. We'd love to have you give feedback on what questions you're interested in. I'll post that link again to the chat. Jerry, on to you.
Thank you, Stuart. And also, Stuart, if you could post the links to everything I'm about to talk about. And folks, I know I'm in the East Coast now. It's getting late here. I'll only be about 15 minutes. Then we'll take your questions, and then we'll look a little bit more if you're willing to stick around with us at exactly how you can impact this issue. So here's what I'm going to talk about. Dana made it pretty clear. I'll be a little bit more specific. Emissions reduced or climate risk increases to what I believe, I'll try to show you, is just an unacceptable level. Like what we'll be passing on to the next generation will be so degraded, we just can't do that. I'll talk about one bill. There are several before Congress, but one of them is both bipartisan and has a significant amount of support. It's got 82 co-sponsors. That's HR 763. And then make the point that policies like this are in place in Europe and in British Columbia, and they've proven to be successful at significantly reducing emissions while growing the economy. We'll take a quick look at that. So brief review, temperatures over the last 2,000 years. And what I'm just trying to show you is they had been really stable for a long time and really for the last 8,000 years. And humanity develops over that time. They're up about 1 degree centigrade. And that's about 2 degrees Fahrenheit. So for a long time, a 57-degree world, now a 59-degree world, and we're beginning to see the stresses. Where are we headed? This is from climateinteractive.org. Again, the link is in the chat. This is MIT's models. They do really good work in this space, and they're really middle of the road. And they're showing 4 distinct paths forward now, and the resulting temperature increases. I'm going to go over 2 of them with you just to show contrast. What happens if we don't do much? What happens if we seriously take action like what our bill can achieve? So let's start with the blue line that says national plans. That is what they're simulating here, is that all countries come together and achieve the national plans that they've set out as part of the Paris Agreement, but don't do anything, don't take any additional measures after that. And many consider this something pretty close to the path that we're on. So to this point, we're up 1 degree centigrade. If we do that by the end of the century, the total temperature increase will be 3.2 degrees centigrade. So temperature increase about 3 times or a little bit more what we're currently experiencing. Climate impacts probably a little bit more than 3 times, probably closer to 4. And that's because, not surprisingly, climate impacts are not linearly related to temperature, but actually a little bit geometric. So the impacts would be worse. So we're looking at, if we stay on this path, about 4 times the impacts of what we're experiencing. Here's the other path. This is consistent with the Paris objectives. They said we've got to go well below 2C temperature increase. We want to keep it to 1.5. And here's what that takes. So note, this is surprising to a lot of people that, as Dana says, haven't been hanging around the climate space for a while. This requires a significant reduction in emissions globally. Right here in about 2050, call that about a 90% reduction in emissions. Pretty dramatic. Yet temperatures still increase, up 1.8 degree centigrade, 1.4 degrees centigrade. That's the 1.5 path. So from 1 to 1.5, impacts will increase, but we can stabilize risk fairly quickly. We can draw it down from there. So here's 2 paths I want to look at. Okay. And this is what I basically said, 3 to 4 times. I can't leave that for my kids. It's hard to imagine civil societies sticking together after allowing ourselves to degrade the planet to that degree. Yet we can stabilize climate risk now. Now, what does that look like? Well, what we've got to this point, stronger storms, okay? a lot of hurricanes, and they tend to be stronger. The wildfire risk Dana just really detailed. Flooding in the Midwest has been way up, and drought in California and elsewhere. And so I'm trying to make it real for you with these pictures. Consider 4 times the impacts from what we've already seen. All right, and there's another element to that, which if impacts don't necessarily concern you, everybody's concerned about expense. So what we have here is data from the NOAA, National Oceanographic and Atmospheric Administration. And what they're looking at here is they track climate and weather-related disasters that cost the US at least $1 billion. And there's no inflation here. This is all completely inflation adjusted in 2019 dollars. So there's an unmistakable trend here. In the 80s, okay, on average, there were a little over 3 such billion-dollar events, and they cost a total of about $17 billion a year. Fast forward to the last decade, and there were almost 12 events a year, and they cost $83 billion. So nearly a 500% increase in cost, largely as a result of climate change. Now, if you just take the last 5 years, the expense total is over 100 billion, 105 billion. So what you see here is that with just a 1 degree centigrade increase in temperatures, you got a 500% increase in climate damages. And so again, I want you to consider what happens if impacts go up 4 times. It looks to me like a condition in which we're spending an enormous amount of society's resources running from climate change and trying to manage the conditions and the degradation stemming from it. We can do better. Again, there are several solutions in front of Congress, good bills. There's a couple of bipartisan ones. This is the one, HR 763, the Energy Innovation and Carbon Dividend Act, that has really garnered some support, largely because of the work of Citizens Climate Lobby, 82 co-sponsors. Here are the original co-sponsors. We've got just the one Republican, Francis Rooney, and he's retiring, and we're hard at work reintroducing the bill in the next Congress and getting more Republicans on it. Here's basically how it works. And I'll give you a website to go to at the end where you can get all the information you can imagine on this, but pretty simple. You charge for pollution. You make it so that pollution is no longer free. There's a carbon fee for all of us, every one of us, every day. So everybody, and this is kind of who we need working at this. At this point, we are behind the 8 ball on climate change. We need everybody every day with a financial incentive to go a little greener. And that's what this does. Now, but that's going to increase your costs. And so we take all of the money and hand it right back to American families. And later in this, I will show you the financial impact on families as a result of that. So you make polluting expensive, you give all the money back. And you put on a border carbon adjustment. Essentially, if we're exporting goods, we reduce that fee at the border so that our exports do not become uncompetitive. We're trying to protect American jobs. We're trying to keep them here. This should do it. But maybe more importantly, imports coming into the country, if they come from a country that doesn't have a like carbon fee on it, then we put that carbon fee on them at the border. This gives the world a financial incentive to start charging for pollution. And that's important because we're only 1/7 of global emissions. So we need everybody participating with us. More to say about that. Now, important to know, Would a bill like this be effective in reducing emissions? Would it get us to the 1.5C? Very recent research from Columbia University, again, the link is in the chat, published in Nature Climate Change, top journal, top model. Here's what they found. Here's a scenario in which emissions drop significantly so that they're at net zero CO2 emissions by 2050. How do you get there? With the carbon fee. Okay, going to the blue sort of bar graph, what the model says is required is a carbon fee of right around $50 a ton by 2025 and $100 a ton. And there's uncertainty around it, and that's why there's some length to the bar. But the mean is about $100 a ton by 2030. Well, HR 763, the Energy Innovation Act, does exactly this. It starts at $15 a ton, goes up $10 a year. By 2025, the fee would be $55 a ton. By 2030, it would be $105 a ton. So we basically are spot on to this objective of net zero emissions by 2050. And if you look back at that MIT graph, you see that that is at or even better than the 1.5C, as long as we can get the rest of the world encouraged to join in with us. And we believe we can. They are waiting to act. We have been the ball and chain on global climate efforts. We are the one that wants to get out of Paris. So is it effective? Absolutely. It's spot on. It'll get us where we need to go in terms of stabilizing climate risk. Health co-benefits. This is something that most people aren't aware of. When you reduce greenhouse gas emissions, you greatly reduce air pollution. Air pollution kills 4 million people a year, and quite a few in the United States. A policy like ours would save 90,000 premature deaths a year, prevent 70,000 hospitalizations and ER room visits, and would save 6 million lost adult work days. And this science, and again, the link is in the chat, is valued at $700 billion a year. So a bill like this pays for itself over and over from day one, just in terms of health benefits. The net benefits to society from something like this, from stabilized climate risk, and you start to level off that bar graph that you saw, improved health and receiving these health co-benefits, really substantial. This thing is a clear winner. Okay, so why aren't we doing it? It must be that it tanks the economy. Absolutely not. Peer-reviewed work, Dr. Noah Kaufman, research scholar at Columbia University, had this to say to the Energy and Commerce Committee on December 5th. Okay, he points to this graph, peer-reviewed work. Now, this is GDP. It's a little dated at the time. This is 2016. This is what GDP was. This is what the model expects GDP to go to in 10 years. It's to grow significantly. Okay, that's the current policy graph. Now they simulate a series, 5 different revenue neutral carbon taxes, just like HR 763. And you just stand back and you get a visual here. And this is what he's trying to show them. You can see the degree to which it just whacks the economy. Well, turns out that's what people say that want to oppose this type of legislation. In fact, it's just fine for the economy. You see here, the first 3 policies actually are expected to increase GDP over the 10-year period. These are policies in which you charge for pollution, the money comes back in the form of reduced payroll taxes. Here's our policy, or a version of it, and there's a slight decline in GDP in 10 years' time. But nothing, so this is down less, like $98 billion. But remember, we're saving $700 billion a year in health benefits, and we're stabilizing climate risk. So clearly, these are good for the economy. We know how to address this. And so here's his summary phrase. I just love this. Studies suggest roughly zero impacts to the overall growth of the US economy from a revenue neutral carbon tax. What about jobs? Turns out a policy like this will create an enormous amount of jobs. Now here's the truth. Here's the dirty little secret. Resources and jobs in the US will shift from polluting industries towards clean industries. When pollution becomes expensive, there is this gentle movement away from polluting industries. So this is from the World Bank. Links in the chat. You put $1 million into oil and natural gas, coal, and you create jobs. Not surprisingly, about 6.9. But if that same money goes into renewables, into wind and solar, it's about twice as many jobs, 13.3, 13.7. If you put it into building retrofits, even more, mass transportation, more than 3 times, closer to 4 times. Here's what we know. Primarily, if you put a carbon fee into the economy, the energy sector will move from fossil fuels to renewables and energy efficiency. In the process, we're going to grow more jobs than we lose. This will be a big time job creator. I think people are starting to realize that. I want to show you something about the impact. Let me see if I've got more here. So this is a study done. It is not peer reviewed yet. The link is in the chat. It's good stuff. Here's the financial impact on households from a policy in which you charge for polluting, give all the money back. Turns out it's really good for the poor. If you look at all households, 61% of households come out with a financial advantage, and that translates to 68% of people, of the populace. So over 2/3 of the people in the country get a financial gain. Costs go up, but they get a check monthly in the mail. The check for 68% of people is bigger than the cost increase. And everybody has a financial incentive to reduce pollution. But in quintile 1, so this is the poorest in the country, 96% do better. This small bar here, this is a minor loss. So it's almost insignificant. It's less than 0.2, so well less, 1/5 of 1% of your income. So 96% come out ahead financially, 3% a minor loss, only 1% of the poorest would lose out. There are environmental justice and social justice concerns in the country right now. We're not doing this to try to redistribute income. We're doing this by just charging an appropriate price for goods that pollute. But in the process, money goes to those that need it most, and it comes from the 5th quintile, really, from people that are most able to afford that. Again, what's happening here is that it turns out our carbon footprint, our pollution, is pretty much a function of the stuff you buy. And people that are wealthy buy a lot more stuff. As a result, they're going to pay more of a fee, and they're going to come out behind in this. And poor people that they buy less, they pollute less on average, 96% gain. That's a good thing. So this has been tried, something like this in Europe. The economy has grown more than it would have, barely. That is the That is the result of peer-reviewed literature that just came out. I don't even have a slide on it. Here's British Columbia, okay? $30 a ton tax started out slowly like ours would. The green line is emissions from gasoline. Looks like it's worked to reduce emissions. The blue line is emissions from gasoline in the rest of Canada. So it's kind of a control group, if you will. It looks like this policy has worked there. Fuel use is down, GDP is up, jobs are up, it's popular. GDP, at least at the time this study was done, we're up more than in the rest of Canada. It works, it doesn't hurt the economy. People like it. Canada has now gone to a $50 a ton tax. So they have added to the program, if you will. So, and I'm just about done here. This explains, and people on the call from CCL are well aware of this slide. This is in an op-ed in the Wall Street Journal last year. This represents the largest public statement by economists in history. Never has there been such a consensus among economists for any policy. And it's really the policy that I just described to you. Again, there's a link. You'll be able to read all about it. 4 former chairs of the Federal Reserve, broad support across the political spectrum. Alan Greenspan and Ben Bernanke on the right, Janet Yellen on the left. 27 Nobel laureates and almost 3,600 economists in total saying we need to address climate change. How you do it is you put a price on carbon and you give all the money back to households. Don't forget to put on a border carbon adjustment. So I want to assert to you that we know what to do. You should be asking, so just a quick summary on the policy. It'll get the job done reducing emissions. It'll create jobs, great for our health. It's bipartisan. We're working hard on that at CCL. It's revenue neutral. It doesn't grow government. I ask myself at this point, wait a minute, if something is so good, why haven't we done it already? And now I'd say get the women and children out of the room for this part because I'm going to say something that will shock you. It turns out in our fabulous American democracy, it's pretty clear that if you're going to institute a policy that's good for the country generally, good even for all life, but you significantly disadvantage a very wealthy, very well-heeled, industry, you can have a tough time. This is a little bit about money versus people. You know, we saw it a little bit with tobacco when it started to become clear that it caused serious health concerns. We've absolutely seen it with climate change. That's okay. I love this country. We're going to get this done, but we need you. We need everybody, whether you do it through CCL or through 350 or the Sierra Club. We need you to have your voice heard on this. Congress is waiting to hear from you. So here's one way to do it. You go to citizensclimatelobby.org. Okay, this is the page that'll come up when you hit take action. Okay, and you'll get full instructions on how to write your congressman, how to call your congressman, a number of other activities. We kind of do it all. It's a fabulous website. You can join CCL. It doesn't cost a thing. And you'll get the information and you'll have access to our intranet site, which will really show you how we do our advocacy. We are 200,000 strong, a lot of fun, and we're working together for an issue that we all deem really critical for ourselves and for the people that we will leave behind.